terms of A yesterday, and we're also going to talk about B really in depth, because I know most of you are getting through B or almost done with B, and have even started C. And then I'll let y'all break up again to go work on C. So for A,
Really quickly, before Ms. Courtney starts going over this, because I want us to think about this, should we all already have some details down for these different functions on A and B for the different equations? Yes. If she covers something that you don't have written down, what should you do?
Write it down.
Write it down. If you made a mistake, what should you do?
Fix it.
Correct it. Now, I do want to point out, when you correct a mistake, that does not mean you have to erase it. Sometimes you want to circle and highlight and note the mistake so that you know how to correct it in the future and you don't make that mistake again. Mistakes are awesome. Investigate them, be okay with them, and learn from them. Okay?
so y'all said we discussed up through number 5 yesterday. Okay, so let's just start on 6. Could 6 be a possible function for this graph of A?
No.
Tell me why.
Because the A is negative, which makes the concavity.
Well, my A is negative, it's concave down, so
No, the vertex. Like,
the okay, so what about the vertex?
It's a swap, so it'd be positive 6 and negative 3. And
Well, we only have to change the sign of something if it's on the inside of the parentheses.
it'll be 6. It'll be
6. We're looking at function 6 of A, 1A.
It'll be 6 and 3.
Okay, but so what form is this equation written in? Vertex. Does vertex tell us what the y-intercept is?
No.
No, it tells us the vertex. So this point would be 6, 3. And I guess this is what I started talking to you guys about the quadrants yesterday. So what quadrant would 6, 3 fall in? Okay, because remember this is quadrant 1, 2. Yeah, so this one would fall in quadrant 1 somewhere. We don't know where because this graph doesn't have any numbers on it. Is that where that vertex is?
No.
Nope, that wouldn't work. So then for your reasoning, you could just write that your vertex is in quadrant 1.
Quick question. If we turn off the lights, could y'all still see and stay awake?
No.
Just because that'll help
Yeah.
the video show up a little bit better. Is that okay?
Yes.
Anybody have a major complaint?
Me, I can't see.
Me.
I can't see.
KT, do you need to move up to group 1 so you can see better?
I'm talking about like I won't be able to see my picture.
KT.
Then you might need to go get some glasses. Go ahead, Miss Courtney.
Wait, with the lights off?
Lights off, yeah.
Yeah, it's true.
Okay, lights off. Okay, so, okay, for function 7, would this be a possible one? Tell me why you say yeah.
No, because R1 and R2 it's gonna be negative 2 and positive 3.
Okay, so what he's saying is R1 and R2, so he's talking about our roots, or our x-intercepts here. We're going to have a negative 2, 0, and then we're also going to have a 3, 0. So that means that one x-intercept would be positive and one would be negative. Is that what this graph shows us? No, this graph gives us what kind of x-intercepts? Yeah, it gives us 2 negatives. So that's why this one wouldn't work. Okay, and then what about function 8? Would that one work?
Yes.
Tell me why.
Because of course A is negative and then the vertex would be negative 6, 3, which is positive.
Okay, so this vertex is negative 6, 3. And let's see, so negative 6, 3 would fall in what quadrant? Okay, somewhere over here. That works. And also, what else about this? The concavity. Alright, nice. Okay, let's start talking about B. Okay, so what is, somebody tell me an equation that would work for B. That you found that would work for B. Okay, let's look at equation 1. What form is that written in?
Vertex.
Okay, so what would the vertex be? The coordinates. Okay, so that would be a positive 75 and a negative 92. So what quadrant would that fall in?
4.
Okay, so that would give us a positive x and then a negative y. Yep, so that would fall somewhere in that fourth quadrant.
Yeah, like you would know.
And then I have a parabola going up because my a is greater than 0, so this one works. What were you saying, Caleb? I'm sorry.
I was saying when K is negative, it drops below the x.
Yeah, so when k is negative, your point's either going to be in this quadrant 3 or quadrant 4, right? So, okay, so what's another one that you guys found worked for this graph? Okay, let's talk about 3. Can you tell me why it works, Therese?
Because y-intercept.
Okay, we have this positive y value for the y-intercept, and then it's also concave up. So even though this isn't crossing the y-axis right now, it will. It will eventually, and when it does, it's going to cross it in the positive region. So that's why we can say that it does have that positive y-intercept. Okay, so why wouldn't number 5 work? F5. Okay, concave down. What is there anything else about it? Yeah, that's the only thing. Because the vertex, it has the same vertex as this one, right? The only thing different about it was that concavity. What about function number 2? Would that one work? Why not?
The x-intercepts are going to be negative.
How do you know the x-intercepts are going to be? Right, so one would be positive and one would be negative. And over here, these are two positive x-intercepts.
Yeah.
So I would say maybe the negative 2, 0 is a negative x-intercept. Okay, so what about function 4? This gives me 2 positive x-intercepts. That one should work, right? Okay, the concavity, that A is less than 0, so that would be concave down. Okay, and what about that last one? What's up with that last function 6? Oh, I guess that's not the last.
There's one.
It's the last, yeah, there's, I'll pull them up. But 6. Okay, the y-intercept is negative. And you can tell by looking at this that this is never going to cross the y-axis at a negative point, right? Okay, so that's, for this one we would say, just label that as the y-intercept, because you're just telling me what feature of that equation contradicts the graph picture. And then we have, okay, 7 and 8, okay, so what about number 7? What form is that one written in? Function 7. Okay, so that concavity's up. Why wouldn't this one work? It would work? What are the coordinates of the vertex?
-4, -2.
Okay, so -4, -2. Oh, that's awful. So -4, am I going to go left or right? Left. Okay, and then -2, up or down? This is B, this is still under B. It's just I couldn't fit them all up here. Right, so that would give me a vertex somewhere down here in quadrant 3, and that's not where this one is, so I guess 7 wouldn't work. Right? Right. Okay, so what about this last one? Oh yeah, it would work, right, because of these two positive x-intercepts. These are supposed to be negative x-intercepts, okay? Do y'all understand why these intercepts would be negative? Does everybody in here understand that these x-intercept, the values of these x-intercepts are going to be negative? Okay. So, okay, so now I want you guys to take some time to look at C. If you've already looked at C and done it, go back and look at your justifications. Make sure you're fully justifying why or why not these equations would work for the graph. Okay, so take a few minutes, work on C, and then we'll come back and discuss them.
That's all. People are always scared to touch your eye.
I'll be doing everything with eyes.
So y'all had already talked about some on C, right? So did you go back and change any, or were they all right? Okay, add more information, that's good. How are y'all? Okay, what's up? Okay.
Positive vertex.
Yes. So A, no matter what anything else is, you still get A for that. Because it can be concave down inside a negative y-intercept.
Oh, give me the order.
You know what I'm saying? Okay, girl. You just wouldn't cross the. So are you saying is that what you're asking? It can be concave down and have a negative y or a negative c for standard form? Because that would, so if it was concave down, that would mean that the a is negative and it would just cross over here or something, right? No, this is, well, so crossing the y-axis is negative in the negative region.
Number 5, yes.
So that C would be negative.
Yes.
Yeah. It could, look, it could have a, so this would be A is less than 0, so it's concave down, but a positive y-intercept. It crosses up there.
In this
So,
standard form.
that's to show you that Just because if your C is positive or negative, it's not gonna change anything on the A.
So why
So
the,
if A is positive, it's still concave up, no matter what. If A is negative, concave down, no matter what. Does that help?
I don't know if that
Yeah,
is
the
right.
sign on the door.
But I did something.
Hey guys, a few more minutes, finish talking about these under C. Yeah,
they ain't do shit there.
we're gonna get go into those. You can start looking at them and thinking about them, but that's our next topic.
I didn't know because there's a bigger Y intercept. That would be in quadrant 2.
6 is standard 2.
Yep.
So the A is positive.
Is this also a job?
You're all about done with C? Okay. Y'all about done with C?
Yeah, I tried, but I don't know if that's right.
Alright, everybody, let's start talking about.
I don't.
Okay, so for 1C, can somebody tell me an equation that would work for this graph?
Number
3.
Okay, let's look at
Yes, ma'am.
3. Okay, what form is 3 written in?
Standard.
Okay, and what things does standard form tell me?
Concavity and Y intercept.
Okay, so let's look at the concavity.
Why
Hey,
not?
Zeus, what's it gonna be looking at that equation?
That'd be concave.
Okay, because that A is greater than 0. And then also the y-intercept would be what? Positive, okay? So, and this is gonna have a positive, I can't reach up there, but it's gonna have a positive y-intercept. When it stretches out and crosses the axis, it's up there. Okay, so I could just write, you can write the coordinates for the y-intercept to tell it's positive. You could say it just has a positive y-intercept because that's what the graph is. Those are reasonable justifications. So what's another one that works for this graph?
5.
Okay, let's look at 5. So this is written in what form?
Vertex.
Okay, vertex. What's the coordinates of the vertex?
Positive 6 and 5.
Okay, 6 and 5. It's gonna be somewhere over here in that first quadrant, right? So somebody in the last class brought up, they're like, well, I mean, it doesn't look like this could be the point of 6, 5 because it's so close to the axes. Well, does this graph have any numbers on it? So we can't determine that kind of detail right now, but we're just still getting the general idea of where this function would be, I guess. So, okay, the vertex, and then what other thing does the vertex formula tell us that,
Concavity.
right, that concavity. Okay, were there any others that could work for C?
No.
Would number, let's see, so would number 1 work?
No.
Why not?
Negative.
Okay, well first, does this graph cross the x-axis at all?
No.
No. Okay, so what about number 2?
X intercept and negative.
Well, not, so remember the vertex is a point, so it can't really be positive or negative, but the values of the points. So this vertex would be what?
Negative 6.
Negative 6. Is that what you meant about negative? Was the okay, I see what you're saying now. So that would be in quadrant what?
3.
Good. Yep, that would be in quadrant 3. And this vertex is in quadrant 1. Okay, base 4 is kind of similar to 1 in the same reason that this graph doesn't cross the x-axis. So,
Negative point,
again,
2 negative point.
yeah. So this is saying that if we graph this, it would be something like that with negative x-intercepts concave up. That's nothing like that, right? And what about 6?
No.
What feature of 6 lets me know that this would not work for the graph?
The y value.
The y value is in quad.
Cool, the negative y value for the y-intercept. Awesome, guys. Okay, let's start looking at, okay, so now we're gonna look at number 2. Can I get somebody to read this for me?
Read it.
Go ahead, Jaquan, read it.
Consider the two functions shown for question 1. Identify the form of the function given and then write the function of the two forms if possible. If it is not possible, explain why.
Okay, so first, let's look at A. What form is this given to us in?
Vertex.
Factor.
Right, so recognize that this is factored form. Okay, and so now we have to algebraically convert from factored form to either standard form or to vertex form. So let's say if we wanted to convert first to standard form, do you guys have any ideas about how we could manipulate this equation to make it look like something else?
Factor.
More specific, ooh.
Combine the term.
Well, before I can combine like terms, I have to do something first. Ooh, distribute. Okay, so why don't you guys take a few minutes in your groups, talk about how we could multiply these things together using the distributive property, and then you'll have to do some combining like terms in there, and we'll come back and talk about it. Okay, so this, and also think about what the standard form of the equation looks like to help you maybe get there. Okay, so take a few minutes and think about that, and we'll come back.
You do negative 2 times everything. That makes sense. Right.
So I got negative 2.
I got negative 4x plus 6.
You have like negative. You gotta add like the negative. You just add negative and subtract. Like combining negatives and adding as well.
We got to add 2 as well.
Oh, I put plus 8 instead of minus 8. That's why I went. After you did all of it? When I was like factoring, I was doing negative 2 times 4, and I put plus 8 instead of minus 8. You know what I'm talking about? Yeah. So which I got negative 4x minus 10. Okay. This is giving 1 mx plus b. Anyway, it's probably gonna be right.
Okay, guys, look up here really quick. So I'm just seeing some things when I've been walking around. So whenever you want to multiply these together, what would your first step be?
Everything inside parentheses.
Okay, so when you say everything inside the parentheses, do you mean this parentheses or that parentheses?
Both.
Just the first one. You can't distribute this 2 to everything. That's,
You're right.
that's, no.
I can't factor.
So what we need to do is, Caleb, tell me what you said.
Distribute two, like everything inside the first parenthesis.
So first we can distribute the 2 to everything inside this first set of parentheses. So what would that give me? Negative 2x minus 2, right? Okay, so now
I put it at that.
I can multiply this parenthesis, this, everything that's on this parentheses times everything that's inside of this parentheses. Okay, does that, do y'all remember that from like algebra 1?
Yes.
Okay, we'll talk, let's go through it. So when I'm using the distributive property, what I need to do is, just like I did here, so this negative 2x, I'm going to multiply it to everything on the inside of the other parentheses, right? But then I also have to multiply this negative 2 by everything over there. Okay, do you see what we're doing here?
Yeah.
Okay, so now let's actually do it. Okay, so let's do this first. Negative 2x times x,
Negative 2x squared.
negative 2x squared. Now do this negative 2x times 4,
Negative 8.
negative 8x.
Yeah.
Is everybody good up to this point?
Mm-hmm.
Okay, so all I've done so far is I multiplied this first term to everything in the other set of parentheses. Okay, now I'm going to do it with the negative 2. I still need to multiply it to everything else. Okay, so it's a negative 2 times x,
Negative 2x.
and then a negative 2 times 4.
Negative 8.
Okay, y'all understand that?
Yes.
It's a process, but does it make sense at least? I multiplied everything in here times everything in here. And I remember I wasn't able to just put this 2 to everything, to multiply it by everything, because this is saying this is negative 2 times x plus 1, and then x plus 1 times x plus 4. It didn't say negative 2 times this and negative 2 times that. Right?
Right.
Won't you slim it down now? You do negative 8 minus 2.
Right, so now let's combine our like terms, so that we're going to have negative 2x squared
Minus 10.
minus 10x.
Minus 8.
Okay, and what form of quadratic equation does that look like?
Standard form.
Standard form. Okay, so now if we wanted to get it in vertex form, what information do we need to write that equation? Can I just write a vertex equation using any points?
No.
What do I need?
X-intercept.
Do I need x-intercepts for vertex form?
No.
No.
I would need what? The
Vertex.
vertex. Okay, so how could I, if I don't know what it is, algebraically, is there another mathematical representation I could use to find what that vertex is? Right,
Yeah.
I could graph either one of these equations, because if I graph this in standard form and this in factored form, it's going to show the same shape on the graph, right? So I could graph it and get the vertex from there and then write it. But we're going to go ahead and go to part B. So part B is given to us how?
Vertex form.
So right, this is given to us in vertex form. So if I wanted to rewrite it in standard form, what would I have to do?
Distribute the 2.
Right, but before I can distribute that 2, I have to take care of this exponent. Right?
Right.
Because this x minus 6 squared means that it's actually being multiplied twice. Like that. Does that make sense? Do y'all see why I rewrote it like that? Because the x minus 6 to the raised to the exponent of 2 means that it's twice.
Yeah.
What do you mean 12? Okay, so now take a few minutes, look at how we did, reference how we multiplied here, okay? simplify this and try to get this equation into standard form. Okay, remember you're multiplying everything in the first set of parentheses times everything in the second set of parentheses.
Yeah, so also don't forget about this plus 5 on the end too that you gotta add back in there. You see what I'm talking about? Oh, okay, I see. So also write it here, in here, just to show that's where it came from.
Alright guys, so can somebody walk me through this distributive process? Okay, so first, if we can do it this way, multiplying this 2, so that would give us 2x minus 12. Okay, now we need to multiply these together. Okay, so somebody walk me through it.
2x squared,
Okay, so that'd be 2 times x is 2x squared.
and then minus 12x.
Okay, so 2x times a negative 6 minus 12x. Okay, that took care of the 2. Now we got to multiply this negative 12 times everything in that set of parentheses.
Negative 12x.
Negative 12x
Okay, I'm now.
plus or minus. Okay, so now it's a negative 12 times a negative 6 plus 72.
Minus 24
And
is
good, guys. Don't forget to bring down that 5 at the end. And also don't forget to write it, don't leave it out to begin with, because that's part of the...
I was gonna add it.
So the 72 comes from the negative 12 times the negative 6. Okay, so then now we have more like terms we can combine. I'll write it up here. So that'd give us 2x squared. Okay, combine into negative 12x's.
Wait, so you,
Yeah, I didn't multiply it.
when you add 5 to 72, it make it negative 67.